The 2003 International Building Code, known as the IBC, mandates exterior illumination at all exits, encompassing commercial occupancies. The reasoning for this requirement is to ensure a secure and well-lit escape route for building occupants during emergencies. While the National Electrical Code, or NEC, doesn't explicitly demand exterior lights at exits from commercial buildings, it does mandate lighting at exits from dwelling units. This distinction arises because dwelling units usually house families who might be more susceptible to risks during emergencies. The IBC doesn't specify the exact number of exterior lights needed at each exit. However, it stipulates that the lights must adequately illuminate the path of egress. This means the light should provide sufficient brightness for occupants to see clearly and safely evacuate the building. Consider a retail strip center with 10 bays, each having 2 exits. In such a case, you would require a total of 20 exterior lights. These lights must be connected to an emergency power source. This ensures their operation even during a power outage. The requirement for emergency lighting at exits is to ensure that occupants can safely evacuate the building during an emergency, even if the power is out. This is particularly important in large or complex buildings. In these buildings, finding your way out in the dark may be challenging. While the primary objective of egress lighting is to facilitate the safe exit of people from the building, it's also essential to provide a well-lit path of egress. This ensures occupants can do so safely. This is especially crucial in areas with potential hazards like uneven surfaces or obstructions. To clarify the code requirements, let's delve deeper into specific sections of the 2003 IBC. Section 1006.1, titled Illumination Required, states that the means of egress, including the exit discharge, must be illuminated at all times the building space served by the means of egress is occupied. This implies that every exit should have exterior lighting to guide occupants safely away from the building. Furthermore, Section 1006.3, subsection 5 of the IBC addresses emergency lighting. It specifies that in the event of a power supply failure, an emergency electrical system must automatically illuminate certain areas. These areas include the portion of the exterior exit discharge immediately adjacent to exit discharge doorways in buildings required to have 2 or more exits. This means that if a building requires 2 or more exits, the exterior lights near those exits must be connected to an emergency power system. This ensures that even during a power outage, occupants can still see the exit pathways clearly. Therefore, in a retail strip center scenario with multiple bays and exits, the interpretation of these code sections suggests the need for exterior lights at each exit powered by an emergency system. This raises a practical question: how far does this requirement extend? Does it only apply to the immediate vicinity of the exit, or does it extend further into the exterior exit discharge area? The code doesn't define a specific distance, leaving room for interpretation based on the specific building layout and potential hazards. The intent is to provide sufficient illumination to guide occupants away from the building and to a safe location. It's important to remember that the primary purpose of egress lighting is to ensure safe evacuation, not to provide continuous lighting for an extended distance. The focus should be on illuminating potential hazards and guiding occupants away from the building in an orderly manner. The NEC also plays a crucial role in ensuring the safety and reliability of electrical systems, including emergency lighting. While it may not explicitly mandate exterior lighting for commercial buildings, it provides guidelines for the installation and maintenance of emergency power systems. This ensures that the emergency lighting systems are properly designed and function correctly during a power outage. The NEC covers various aspects of emergency power systems, including the type of power source, the wiring methods, and the testing and maintenance requirements. Compliance with the NEC is essential to ensure that the emergency lighting system is safe and reliable. Now let's consider the specific scenario of a retail strip center with 10 bays, each having 2 exits. According to the IBC and the interpretation discussed, each exit should have an exterior light powered by an emergency system. This means a total of 20 lights, 10 in the front and 10 in the back, connected to an emergency power source. This may seem extensive, but it's important to remember the primary goal of ensuring safe evacuation during an emergency. The emergency power source could be a generator or a battery backup system. The choice depends on factors such as the size of the building, the number of emergency lights, and the desired duration of emergency power. The emergency power system must be capable of providing sufficient power to all the emergency lights for a minimum duration, as specified by the IBC. In addition to the emergency lighting requirements, the IBC also specifies the minimum level of illumination required for the means of egress. Section 1006.2, titled Minimum Illumination, states that the means of egress must be illuminated at a minimum of 1 foot candle at the floor surface. This ensures that occupants can see clearly and safely navigate the exit pathways. The illumination level should be measured at the floor surface along the path of egress. The light should be positioned and directed to provide uniform illumination and minimize shadows. It's also important to consider the color rendering index, known as the CRI, of the light sources. The CRI measures the ability of a light source to accurately render the colors of objects. A high CRI is desirable to ensure that occupants can accurately identify potential hazards and navigate the exit pathway safely. In summary, the 2003 IBC requires exterior illumination at all exits from commercial buildings, and these lights must be powered by an emergency system if the building requires 2 or more exits. The purpose of these requirements is to ensure the safe evacuation of occupants during an emergency, even if the power is out. The NEC provides guidelines for the installation and maintenance of emergency power systems to ensure their reliability. Now let's delve into the practical considerations of implementing these requirements in our retail strip center. Firstly, it's important to consult with a qualified electrical engineer or contractor to design and install the emergency lighting system. They can assess the specific requirements of the building and ensure that the system complies with all applicable codes and standards. Secondly, the selection of appropriate light fixtures is crucial. The light fixture should be durable, weather-resistant, and energy efficient. They should also provide adequate illumination and have a high CRI. Thirdly, the emergency power source must be reliable and capable of providing sufficient power for the required duration. Regular testing and maintenance of the emergency power system are essential to ensure its readiness in the event of a power outage. Fourthly, the placement of the exterior light should be carefully considered. The light should be positioned to illuminate the entire path of egress and minimize shadows. They should also be protected from vandalism and accidental damage. Fifthly, regular inspections and maintenance of the emergency lighting system are necessary. This includes checking the light fixtures, the emergency power source, and the wiring connections. Any damaged or malfunctioning components should be promptly repaired or replaced. Lastly, it's important to train building occupants on the location of the exits and the operation of the emergency lighting system. This will help them to evacuate the building safely and efficiently during an emergency. In addition to the technical aspects of emergency lighting, it's also important to consider the psychological impact of lighting on occupants. Bright, well-lit spaces can promote a sense of safety and security, while dim or poorly lit spaces can create feelings of anxiety and fear. The design of the emergency lighting system should take into account these psychological factors to create a positive and reassuring environment for occupants. The use of warm, natural colored light sources can help to create a more comfortable and welcoming atmosphere. The avoidance of harsh, glaring light can also reduce stress and fatigue. By carefully considering the psychological impact of lighting, it's possible to create an emergency lighting system that not only provides adequate illumination but also promotes a sense of well-being among occupants. Furthermore, advancements in lighting technology have led to the development of more energy-efficient and environmentally friendly lighting solutions. The use of LED, or light-emitting diode, lighting can significantly reduce energy consumption and lower operating costs. LED lights also have a longer lifespan than traditional light sources, reducing the need for frequent replacements. In addition to LED lighting, other energy-efficient lighting technologies such as compact fluorescent lamps, known as CFL, and induction lighting, can also be used. The selection of the most appropriate lighting technology depends on factors such as the desired illumination level, the energy efficiency requirements, and the budget constraints. By adopting energy-efficient lighting technologies, building owners can reduce their environmental impact and save money on their energy bills. In conclusion, the requirements for exterior illumination at exits from commercial buildings are intended to ensure the safe evacuation of occupants during an emergency. Compliance with the IBC and the NEC is essential to ensure that the emergency lighting system is properly designed, installed, and maintained. By carefully considering the technical, psychological, and environmental aspects of emergency lighting, building owners can create a safe, comfortable, and sustainable environment for occupants. And by doing so, they can contribute to a safer and more secure community. Let's expand on the maintenance aspects of emergency lighting systems. Regular maintenance is crucial to ensure that the system functions correctly when needed. This includes periodic testing of the emergency power source, such as generators or battery backup systems. Generators should be started and run for a specified period to ensure they are operating correctly. Battery backup systems should be tested to verify that they can provide power for the required duration. In addition to testing the power source, the light fixtures themselves should also be inspected regularly. Check for burned out bulbs, damaged lenses, and any other signs of wear and tear. Replace any damaged or malfunctioning components promptly. Wiring connections should also be inspected to ensure they are secure and free from corrosion. Loose or corroded connections can cause the system to malfunction. It's also important to keep the light fixtures clean. Dirt and dust can accumulate on the lenses, reducing the amount of light that is emitted. Clean the lenses regularly with a soft cloth. Furthermore, keep the area around the light fixtures clear of obstructions. Trees, bushes, and other objects can block the light and reduce its effectiveness. Trim any vegetation that is blocking the light. In addition to regular maintenance, it's also important to keep accurate records of all inspections, tests, and repairs. This documentation can be helpful for troubleshooting problems and demonstrating compliance with codes and standards. The record should include the date of the inspection, the name of the person who performed the inspection, and any findings or corrective actions taken. Proper maintenance of emergency lighting systems is not only a legal requirement but also a moral obligation. By ensuring that the system is functioning correctly, you are helping to protect the lives of building occupants. Let's discuss the various types of emergency lighting systems that are available. One common type is a central battery system. In this system, a central battery bank provides power to all the emergency lights in the building. The battery bank is typically located in a dedicated room and is connected to the normal power supply. When the normal power fails, the battery bank automatically switches on and provides power to the emergency lights. Central battery systems are typically used in large buildings with a large number of emergency lights. Another type of emergency lighting system is a self-contained unit. These units contain their own battery and light source. They are typically used in smaller buildings or in areas where it is not practical to install a central battery system. Self-contained units are easy to install and maintain. However, they may not be as reliable as central battery systems. A third type of emergency lighting system is a generator-based system. In this system, a generator provides power to the emergency lights when the normal power fails. Generators are typically used in buildings where it is critical to maintain power during an outage, such as hospitals and data centers. Generator-based systems are very reliable, but they can be expensive to install and maintain. The selection of the most appropriate type of emergency lighting system depends on factors such as the size of the building, the number of emergency lights, and the budget constraints. It's important to consult with a qualified electrical engineer or contractor to determine the best system for your needs. Let's discuss the importance of proper documentation for emergency lighting systems. Proper documentation is essential for demonstrating compliance with codes and standards, troubleshooting problems, and planning for future maintenance. The documentation should include a complete set of drawings showing the location of all emergency lights and the wiring connections. The drawing should also include the specifications for the light fixtures and the emergency power source. In addition to the drawings, the documentation should also include a written description of the system. This description should include the type of system, the operating procedures, and the maintenance requirements. The documentation should also include a record of all inspections, tests, and repairs. This record should include the date of the inspection, the name of the person who performed the inspection, and any findings or corrective actions taken. All documentation should be kept in a safe and accessible location. It should be readily available for inspection by authorities and for use by maintenance personnel. Proper documentation is an essential part of an effective emergency lighting program. It can help to ensure that the system is functioning correctly and that it is properly maintained. Let's explore the topic of emergency lighting in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. Emergency lighting in hazardous locations must be specially designed and installed to prevent ignition of these flammable substances. The NEC specifies the requirements for emergency lighting in hazardous locations. These requirements include the use of explosion-proof light fixtures, intrinsically safe wiring methods, and other safety measures. Explosion-proof light fixtures are designed to contain any explosion that may occur inside the fixture. They are typically made of heavy-duty materials such as cast aluminum or stainless steel. Intrinsically safe wiring methods are designed to limit the amount of energy that can be released in the event of a fault. This reduces the risk of ignition. In addition to the NEC requirements, other codes and standards may also apply to emergency lighting in hazardous locations. It's important to consult with a qualified electrical engineer or contractor to ensure that the system complies with all applicable requirements. Emergency lighting in hazardous locations is a critical safety measure. It can help to prevent fires and explosions and to protect the lives of workers. Let's now consider some common problems with the emergency lighting systems and how to troubleshoot them. One common problem is burned out bulbs. Bulbs can burn out due to age, voltage fluctuations, or other factors. The easiest way to troubleshoot a burned out bulb is to simply replace it. However, it's important to identify the cause of the burnout so that you can prevent it from happening again. Another common problem is a dead battery. Batteries can die due to age, overcharging, or undercharging. The best way to troubleshoot a dead battery is to test it with a battery tester. If the battery is dead, it will need to be replaced. A third common problem is a faulty wiring connection. Wiring connections can become loose or corroded over time. This can cause the system to malfunction. The best way to troubleshoot a faulty wiring connection is to inspect it visually. Look for loose wires, corroded terminals, and other signs of damage. If you find any problems, repair or replace the wiring connection. A fourth common problem is a malfunctioning emergency power source. The emergency power source may fail to start or may not provide sufficient power. The best way to troubleshoot a malfunctioning emergency power source is to follow the manufacturer's instructions. This may involve testing the generator, checking the fuel level, or inspecting the battery. If you are unable to troubleshoot the problem yourself, contact a qualified electrical engineer or contractor. It's important to troubleshoot emergency lighting problems promptly to ensure that the system is functioning correctly. Let's discuss the importance of regular training for personnel who are responsible for maintaining emergency lighting systems. Regular training is essential for ensuring that personnel have the knowledge and skills necessary to perform their duties safely and effectively. The training should cover topics such as the basics of emergency lighting systems, the requirements of applicable codes and standards, the procedures for inspecting and testing the system, and the methods for troubleshooting common problems. The training should also include hands-on practice. This will give personnel the opportunity to apply their knowledge and skills in a realistic setting. The training should be conducted by a qualified instructor who has experience in emergency lighting systems. The instructor should be able to answer questions and provide guidance. The training should be repeated periodically to ensure that personnel stay up to date on the latest information and best practices. Regular training is an investment in safety. It can help to prevent accidents, reduce downtime, and improve the overall performance of the emergency lighting system. Let's delve into the specifics of lighting control systems and their integration with emergency lighting. Lighting control systems are used to manage and automate the operation of lighting fixtures. They can be used to turn lights on and off, dim lights, and adjust the color temperature of lights. Lighting control systems can be integrated with emergency lighting systems to provide a more sophisticated and efficient solution. For example, a lighting control system can be programmed to automatically turn on the emergency lights when the normal power fails. The lighting control system can also be used to dim the emergency lights to conserve energy. In addition, the lighting control system can be used to monitor the status of the emergency lighting system and to alert personnel of any problems. The integration of lighting control systems with the emergency lighting systems can provide a number of benefits, including improved energy efficiency, enhanced safety, and reduced maintenance costs. However, it's important to ensure that the lighting control system is compatible with the emergency lighting system and that it is properly configured. It's also important to ensure that the lighting control system does not interfere with the operation of the emergency lighting system. The integration of lighting control systems with emergency lighting systems is a complex topic. It's important to consult with a qualified electrical engineer or contractor to ensure that the system is properly designed and installed. Let's discuss the advancements in wireless technology and their impact on emergency lighting systems. Wireless technology is becoming increasingly popular in emergency lighting systems. Wireless systems offer a number of advantages over traditional wired systems, including lower installation costs, greater flexibility, and improved scalability. Wireless emergency lighting systems use wireless communication protocols to connect the emergency lights to a central control unit. The central control unit can be used to monitor the status of the emergency lights, to control their operation, and to receive alerts in the event of a problem. Wireless technology can also be used to integrate emergency lighting systems with other building systems, such as fire alarm systems and security systems. For example, a wireless emergency lighting system can be programmed to automatically turn on the emergency lights when the fire alarm system is activated. The use of wireless technology in emergency lighting systems is still relatively new. However, it is expected to become more widespread in the future. Wireless technology offers the potential to significantly improve the performance and efficiency of emergency lighting systems. Let's talk about the role of daylighting in emergency lighting design. Daylighting is the use of natural light to illuminate buildings. Daylighting can be a valuable asset in emergency lighting design. It can provide a source of illumination during a power outage, reducing the need for artificial emergency lighting. However, it's important to consider the limitations of daylighting. Daylighting is only available during the day, and it may not be sufficient to provide adequate illumination in all areas of the building. In addition, daylighting can be affected by weather conditions such as cloud cover. The integration of daylighting into emergency lighting design requires careful planning. It's important to consider the availability of daylight, the illumination requirements of the building, and the potential for glare. It's also important to ensure that the emergency lighting system can provide adequate illumination even when daylighting is not available. Daylighting can be a valuable asset in emergency lighting design. However, it should not be relied upon as the sole source of illumination. The emergency lighting system should be designed to provide adequate illumination in all conditions. Let's examine the sustainability aspects of emergency lighting. Sustainability is becoming an increasingly important consideration in all aspects of building design. Emergency lighting is no exception. There are a number of ways to make emergency lighting systems more sustainable. One way is to use energy-efficient light fixtures. LED light fixtures are much more energy efficient than traditional incandescent or fluorescent light fixtures. Another way to make emergency lighting systems more sustainable is to use daylighting. Daylighting can reduce the need for artificial emergency lighting, saving energy. A third way to make emergency lighting systems more sustainable is to use renewable energy sources. Solar panels can be used to power emergency lighting systems, reducing reliance on fossil fuels. In addition to these measures, it's also important to properly maintain emergency lighting systems. Regular maintenance can help to ensure that the system is operating efficiently and that it is not wasting energy. The sustainability of emergency lighting systems is an important consideration. By taking steps to make these systems more sustainable, building owners can reduce their environmental impact and save money on their energy bills. Let's now consider the future trends in emergency lighting. The field of emergency lighting is constantly evolving. There are a number of trends that are expected to shape the future of emergency lighting. Firstly, the use of LED technology is expected to continue to increase. LED light fixtures are becoming more affordable and more efficient. Secondly, the integration of wireless technology is expected to become more widespread. Wireless technology offers a number of advantages over traditional wired systems. Thirdly, the use of smart lighting controls is expected to become more common. Smart lighting controls can be used to optimize the performance of emergency lighting systems and to reduce energy consumption. Fourthly, the focus on sustainability is expected to intensify. Building owners are becoming more aware of the environmental impact of their buildings. Fifthly, the emphasis on safety and security is expected to continue. Emergency lighting systems play a critical role in ensuring the safety and security of building occupants. These trends are expected to drive innovation in the field of emergency lighting. The future of emergency lighting is bright. With the continued development of new technologies and the increasing focus on sustainability, emergency lighting systems are expected to become more efficient, more reliable, and more sustainable. Finally, let's summarize the key takeaways regarding commercial building exit lighting requirements. It's essential to understand that the International Building Code mandates exterior illumination at all exits for commercial occupancies, primarily to ensure safe egress during emergencies. While the National Electrical Code doesn't explicitly require exterior lighting for commercial exits, it does for dwelling units, reflecting a greater emphasis on the safety of residential occupants. The number of lights required is determined by the need to adequately illuminate the egress path, enabling clear and safe evacuation. Emergency power is a critical component, ensuring lighting functionality even during power outages, especially in buildings with multiple exits. This requirement, while seemingly extensive in scenarios like retail strip centers, underscores the priority of safe evacuation over simply exiting the building. Regular maintenance, proper documentation, and trained personnel are crucial for the reliability and effectiveness of emergency lighting systems. The integration of advanced technologies like wireless systems and smart controls is enhancing the efficiency and responsiveness of these systems. Sustainability is also an increasingly important consideration, with energy-efficient lighting and renewable energy sources playing a key role. By adhering to these guidelines and best practices, building owners and managers can ensure the safety and well-being of occupants in the event of an emergency. Remember to always consult with qualified professionals for specific design and installation needs to comply with all applicable codes and standards.